Now let's look at the ignition system and start systems. The controls and indicators for the ignition and starting systems and the pedestal. There are 2 low-energy igniters per engine with no time limits. Either the number 1, number 2, or both igniters may be selected. The start selector is a 5-position switch. Click on the left start selector to select the ground position. Selecting the ground position opens the starter valve and arms the selected ignition circuit. The selector is magnetically held in this position. When the fuel control switch is set to run, the ignition circuit is completed to the igniter. At 50% N2, power is interrupted to the start selector and it moves to auto. This deactivates the ignition circuit and commands the start valve closed. The engine start valve light illuminates when the start valve is not in the commanded position, or the valve is open with N2 RPM above 50%. In the auto position, if the flaps are out of the up position or engine anti-ice is on, the selected igniter operates continuously. Selecting the continuous position provides continuous ignition to the selected igniter. The flight position provides ignition to both igniters, no matter which igniter is selected. Next, we'll discuss the electronic engine control. Power is provided to the EEC from an independent engine-driven EEC generator. If the EEC generator fails, the engine shuts down. The plastic-guarded EEC alternate power switches are located on the overhead panel. When normal is illuminated, the EEC is powered by its own EEC generator. When alternate is selected, the associated light illuminates indicating the EEC is now powered from the hot battery bus. The switches are for ground use only. The EEC controls all aspects of engine operation to assure optimum performance. The EEC automatically compensates for changing flight conditions and provides thrust limit protection to prevent engine overspeed and overboost. There are 2 EEC channels for each engine, designated primary and secondary. Both channels operate continuously, and each channel is fully capable of controlling the engine. Each channel has 3 operating modes: EPR, N1, and N2. Both engines normally operate in the primary channel EPR mode to control thrust. Automatic switching from the primary to secondary channel occurs when the primary channel becomes incapable of controlling the engine. However, when the primary channel is inoperative, The secondary channel can control engine thrust in only the N1 and N2 modes. If both EPR modes and N1 modes fail, the EEC automatically selects the N2 primary channel. With the N2 mode in control of the engine, overboost and overspeed protection is not available. This is indicated by the engine limit protection light located beneath the fuel control switches on the pedestal and an associated ICAS advisory message. Takeoff with the engine limit protection light illuminated is not permitted. If the throttle is advanced to full forward, an aural caution alert sounds, and the advisory message changes to a caution message. At any time, should N2 exceed 105% in any mode, the engine is down-trimmed to a fixed thrust setting of 87%. This condition can only be reset by shutting down and restarting the engine. Now try a few questions. Now let's discuss the thrust management system. The thrust management system computes a thrust reference limit for manually setting the throttles, or to control the auto throttles when engaged. Thrust management inputs include altitude and temperature data from air data computers, and the desired mode selected by the pilot or the flight management computer. Thrust modes are selected manually from the Thrust Mode Select panel, located on the center instrument panel. Thrust modes can also be automatically selected by the FMC when VNAV is engaged. Selectable thrust limit settings are takeoff, go-around, climb, continuous, and cruise. Derated thrust limit settings for takeoff and climb may also be selected. The selected limit is displayed as a digital readout and a green reference bug. On the ground, the takeoff limit is automatically displayed. Pressing the takeoff go-around switch while airborne displays the go-around limit for go-around thrust. The go-around thrust limit is automatically displayed at glide slope intercept or when flaps are extended. Click on the appropriate switch to display the max climb limit. Click on the appropriate switch to display the max climb limit. Click on the appropriate switch to display the max continuous limit. Now click the appropriate switch to display the maximum cruise thrust limit. For low gross weights or favorable flight conditions, the engines can be operated for takeoff and climb at reduce thrust settings by the fixed derate switches. Pressing the number 1 derate switch on the ground derates takeoff thrust by a fixed value. A green 1 after the takeoff mode indicates a derated 1 setting. The number 2 derate switch derates takeoff thrust by a greater value, which is indicated by a green 2 appearing after the takeoff mode. If takeoff 1 or takeoff 2 is used, pressing climb will give climb 1 or climb 2 power. To deselect an alternate takeoff or climb thrust limit, the respective derate switch is pressed again to return engine thrust to maximum takeoff or climb power. A thrust reference selector located on the ICAS control panel overrides the thrust management system to manually set the thrust limit. Pulling out on the inner control allows the thrust limit to be set manually, and the letters MAN appear as the mode enunciation. Rotating the selector sets the desired target EPR. Auto throttles do not use this target value. The outer control selects the EPR indicator to be set